So now we can move on to question 3. Question 3 is a truth table logic gates question, and it says complete the truth table for the following logic circuit. So let's do that. We've got our 3 inputs, A, B and C. Here we are, A, B and C, and we've got our output X, so that's what we're getting here. And we've got a workspace in between which we're going to use. So the best way to do this is to just sort of carve up your workspace a little bit so it gives you extra columns. And I can see we've got a NOT gate going into C. So that's the first thing I will do is I always do a NOT C or a NOT gate if there's any there. So I'll do a NOT C. So let's do that first. So that's this gate here I'm doing first. So we'll just do the opposite of whatever the gate is. There we are. And then we can move on and look at the next part. So I'll probably do this gate here because that's a nice easy OR gate. So if we do that column there, we've got B. So we've got B or NOT C. So we can write that on. We're doing that one. So this is B or NOT C. We'll give it a label. I'll call it P. So P is equal to B or NOT C. So let's do that. So B and NOT C. So we have a 1 there, a 0 there, a 1, a 1, a 1, a 0, a 1, and a 1. Remembering that if with an OR gate, if either one or both of the inputs are 1, then the output is always 1. So the only time we have a 0 is where both B and NOT C are 0. So that's that gate done. So then we can do this gate here. So this gate here is A, X or B. So A, X or B, we'll give it a label, we'll call it Q. So we'll call that Q. So A, X or B, so Q equals A, X or B. So let's work out that. So remember that with an XOR gate, you want both inputs to be different to have a 1. If they're both the same, then they will be a 0. So they are both the same, so that's a 0, a 0. They're different on that one, and they're different on that one, and that one, and that one, but they're the same there and the same there. So that's that one there. So then we can do our final X column here, and we've got P and Q, which are going to be XOR together. So X is finally going to be basically Q XOR P. So we can just take those two columns there and XOR them together. We're just looking for them being different for an output of 1. So I can see that that's those 3, I think, are the only 3 that are different, and everything else is the same. It doesn't matter if it's a 0 or a 1. So that's my final answer. Let's check that against the mark scheme, which should be this one here. Yep. So we've got the first one and the last 3 as being a 1, and that's right. Yep. That's right, that's right, that's right. So we're getting marks for that. We're getting a mark for every 2 rows basically that are correct. So if we go back, we can see there that we'll get 4 marks for that. So 2 marks for that, or 1 mark for that, 1 mark for that, 1 mark for that, 1 mark for that. So that's 4 marks. So now we can move on to part B of the question, and this one says draw a logic circuit which corresponds to the following logic statement. So for this one we have our logic statement here. We need to draw it on. So what I'm going to do is I'm going to look for the central gate. There's always one gate that goes here, and we're looking for a gate where there's 2 inputs. And you can tell by the brackets that there's 2 inputs, and you can see here there's brackets here and there's brackets here and here. So that's our central gate there, our OR gate by the brackets. So let's just draw an OR gate in here. Excuse my drawing, I'm not very good at drawing logic gates, I'm sorry about this. It's a well-known joke with my students that I'm absolutely appalling at drawing a logic gate, so I'll do my best. So that always has 2 inputs. It's GCSE, there's always 2 inputs into our logic gates. So that's our central gate there, we've done that OR gate. And then we've got two sides to this OR gate, two inputs to this OR gate. So we'll take this side first, and because it looks easier. So we've got one gate there. Oh, I'll stop moving the screen. We've got one gate there, an AND gate. So we can just draw that in, because that's going to be the output. And then we've got not B going in and C. So where C equals 1, that's just straight input. But we've got not B, so we need to draw a NOT gate in that goes in before it goes into that input there. So that is that side done, so we can sort of cross that out. And then finally over here, actually I'll just show you again what that is in case you want to see. So the final bit we've got two gates in this one. We've got an AND gate here and we've got an OR gate here. So we need to try and figure out which one to do first, but actually it's this one here, because the AND gate, because it's got two sides to it first. The brackets kind of define things separately. So we'll do the AND gate there, and we've got C is 1, so we can sort of steal C from up here, and I'll just draw that on there. And then we've also got the output from another section here. That's an OR gate, so we will draw that OR gate on. Again, my drawing is rubbish. That looks pretty bad. Let's try that again. That's really not drawn very well at all. Let's try again. There we go. And we've got two inputs to that. One is B, so we can just steal B before it's knotted, and then we've got not A. So my NOT gate is a little bit squished, but yeah, you can see it's not A. So A is not 1. So that's the NOT gate. If you do find, it's always a good idea if you're doing, if you have to you get this question in the exam like this where you have to draw something, do it in pencil first and then draw over it in pen afterwards. Always draw it in pen afterwards, because you might do what I've just done there and end up with no room. But hopefully you won't make that mistake as well. So that is our diagram. Let's check the result for that. You can see here that is exactly what I've got, although obviously it's drawn a bit nicer than mine. And you get one mark per section that you get right. Okay, so let's go back to our question, and we have part C for this one, and it says write a logic statement which corresponds to the following logic circuit. So the way that we do this is we start off with our rightmost gate, and we always write in x equals as well, so that's the first thing to do. But then we look at what that gate is. That's an AND gate, so we just write that in the middle. So we've got lots of space left and right of that. Then we work our way down the inputs, and we say, what input have we got there? We've got an OR gate. So on one of the sides we write an OR to represent that gate, and then we follow each one of those two inputs. So the first one is B, so we can say B OR, and then we've got a NOT gate with C, so it's not C. And then we can just bracket those off. Then we do the same on the other side. We follow the line down, and we've got another OR gate, so we just write an OR gate in the middle there, so there's space either side to write both inputs. And you can see that actually from that OR gate we've got A and we've got B going in, so it's A or B and B or not C. So I'll just remove those squiggles, as you can see. So let's have a look at the result. So you can write any of these. There's lots of ways you can write it. You can write it in Boolean algebra if you'd like to. That's perfectly acceptable. You can write it in that way. You can write it with the equals 1. It's totally up to you, and you can write it this way too. So so you know, they will accept equivalent. There's many ways to write this. So that's the way I wrote it there.